I'm going to begin with the why of network monitoring. How do you know what is going on in your network? Is it healthy or is it about to crash? Network administrators really hate to be surprised by failures in their networks, especially ones that could have been foreseen and therefore kept from happening. How do they keep from being surprised? Well, they enact a plethora of procedures and tools to monitor their networks and to keep track of how those networks are behaving. They do this to reduce the surprise element. Now that we've covered the why of network monitoring, let's talk about tools that you can use to monitor the network. One of the main tools that network administrators use to monitor their networks are log files. All operating systems offer a means of viewing events that occur to that specific machine. That also includes networking equipment. There have been some applications that have been developed to monitor systems and networks that also generate log files, among other actions that they can take. Log files can be used to help pinpoint when a problem occurred and to help narrow down the possible causes of that problem. Log files can also be used to help create a baseline of network behavior so that you know what to expect from your network. Log files can usually be classified as being systems logs, general logs, or history logs. As a general rule, log files are an after-the-fact means of monitoring the network, and they're not very good at real-time analysis. That's partially due to the sheer amount of information that log files can generate. It's just too difficult to keep track of that in real time. Now let's talk about some specific logging tools that you can use. The first one that I'm going to talk about is Event Viewer. It's not really a log file in itself. It comes with Windows Server and most other Windows operating systems, and this tool can be used to review Windows log files. The most important log files that you can view from Event Viewer are application, security, and systems logs. Application logs contain events that are triggered by the actions of an application. For example, if you have Live Update enabled, it will create log entries based on actions taken by Live Update. Then there are security logs. These contain events that are triggered by security events. For example, some logs are created for successful and unsuccessful logon attempts. Then there are systems logs. These contain events triggered by Windows systems components. For example, it will create an entry for when a driver starts or fails to start. In either situation, a log entry will be created. Now let's talk about a non-Microsoft log, and that would be syslog. Syslog was developed in the 1980s, and it provides devices that normally would not be able to communicate with a means of delivering performance and problem information to systems administrators. This permits there to be separation between the software that generates the message, the storage of that message, and the software that analyzes the generated message. This separation of function allows syslog to be highly configurable and has allowed it to continue to be a vital tool for monitoring networks even today. As a matter of fact, the Internet Engineering Task Force, the IETF, liked syslog so much that they standardized it in 2009. Syslog can generate log messages based on the types of services that are running, and it includes a severity level that ranges from 0, the most severe, up through 7, the least severe. Syslog can generate a lot of log messages. Most network administrators configure it so that they only get alerted when a minimum severity level has been reached. As a matter of fact, you almost never want to capture debug log events unless you are actively debugging an application or service, just because it generates so much information. Syslog can be configured so that network administrators receive their alerts via text message or SMS message, or by email, or they may even receive a voicemail message. Well, syslog is a cool tool. It's not the only one that's out there. There's also Simple Network Management Protocol, SNMP. SNMP is an application layer protocol used to monitor and manage a network's health. Network or systems administrators configure monitors, these are often called traps, on devices that view the operation of a specific item. As in, is that router's interface up or is that router's interface down? The monitors periodically communicate with a network management station, or NMS, through GET messages, that's GET messages, that the NMS sends out. The response from the monitors is stored in a management information base, or MIB, which is a type of log file. The administrator can custom configure the monitors with set messages sent from the network management station. When an event occurs, as in the interface goes down, the trap is tripped and the event is logged. SNMP, just like syslog, can be configured to just log the event, or it can be configured to contact the network administrator. SNMP gives network and systems administrators the ability to provide more real-time monitoring of a network's performance and health. Then there's Security Information and Event Management, SIEM. It's a term for software products and services that combine Security Information Management, or SIM, and Security Event Management, SEM. SIEM may be provided by a software package, a network appliance, or as a third-party cloud service. It is used as a means of monitoring and providing real-time analysis of security alerts. That is an example of the Security Event Management function, the SIEM function. It can also be used as a tool to analyze long-term data in log files. That's an example of the SIEM function, or the Security Information Management function. SIEM can be highly configured to the needs of the individual network. I'm going to begin by talking about active network monitoring tools. Port scanners are used to scan a network for open ports and protocols. The information that a port scanner gathers is vital information if you want to harden the network. Port scanners are a great method of finding vulnerabilities in the network infrastructure, allowing the network administrator to plug those vulnerabilities before they become a security breach. I do have to issue a word of caution. You should only use a port scanner on a network or system that you are authorized to scan. Port scanning is a possible sign of someone trying to breach a system and can lead to problems if you're not authorized to scan that system. You don't want to have to try and explain to an information security specialist why you were scanning their network if you're not authorized to scan it. A little bit different than a port scanner are applications that use interface monitoring or packet flow monitoring. These are usually deployed as an active software tool to monitor and analyze network traffic within a network segment. They're commonly called packet sniffers or protocol analyzers. They allow for an in-depth look at what traffic is on the network and may reveal security issues that the network administrator can then mitigate. They help to identify top talkers on a network segment. Top talkers are those nodes or applications that generate the most amount of traffic. Packet sniffers can help to identify top listeners on a network segment. A top listener is that interface or the interfaces that are receiving the most network traffic, or put another way, those interfaces that are utilizing the most bandwidth for receiving packets. This can help an administrator when they have determined that load balancing might be needed on the network. Microsoft Message Analyzer and Wireshark are examples of free packet flow monitoring tools. Now let's move on to wireless monitoring tools. And we're going to begin with the Wi-Fi analyzer. A Wi-Fi analyzer is a similar tool to a protocol analyzer, but only for wireless networks. It sniffs out packets on wireless networks and gives you statistics on those packets that it sees. It can check for bandwidth usage, channel usage, top talkers, top listeners, etc., just like a packet sniffer can. Wi-Fi analyzers can also identify networks by passively scanning the radio frequencies to determine where traffic is coming from. Given enough time, a Wi-Fi analyzer can also identify hidden networks, or those that you don't know about. A Wi-Fi analyzer can also infer non-beaconing networks based on data traffic over the radio frequencies. They may not be able to discover the SSID, but they can tell the network administrator that something is passing traffic there. Another type of wireless monitoring tool are wireless survey tools. They're most commonly used as a design tool for setting up high-quality wireless networks. When used in conjunction with mapping tools, the survey tools can help to establish the required amount of access points to get the proper amount of coverage, the ideal antenna placement, and the optimum amount of channel overlap. Wireless survey tools can also help to identify possible sources of radio frequency interference, or RFI. Wireless survey tools are often used to eliminate wireless network performance and security issues before they ever have a chance to occur. Let's move on to environmental monitoring. A network's health can be affected by more than just a network interface failing or a possible security breach. Network and systems administrators also need to be concerned about environmental factors. Some of those factors include the quality and quantity of electrical power being supplied to their equipment, and the amount of heat in the rooms that equipment is kept, and also with that, the humidity level. Power monitoring tools are systems and tools that can be used to evaluate the amount of and the quality of the electrical power being delivered to the system. They're often deployed with or alongside an uninterruptible power supply, or UPS. The monitor will issue an alert when an issue with electrical power has been identified, giving the network or system administrator a chance to rectify the problem before any equipment has been damaged. All electrical components are designed to operate within a specific heat range. Not only are they designed to operate within that heat range, but all electrical equipment will generate some heat while they're in operation. And the harder that equipment works, the more heat they will generate. This is where heat monitors come into play. The heat monitor allows an administrator to control the temperature levels before they become an issue. Humidity is another item that network administrators need to keep in mind. Too little humidity increases the risk of electrostatic discharge, or ESD, but too much humidity increases the risk of condensation on equipment, and your electrical components do not like that condensation. Humidity monitors allow administrators the ability to control the humidity level through the proper means before it becomes an issue.